mass 5 kg lies on a rough horizontal platform. If a horizontal force of 8 Newton applied to the block through its center of mass just slides the block on the platform, then the coefficient of limiting friction between the block and the platform is, so let's quickly take that. So, solution. Now, let's take out the parameters. A metal block of mass 5 kg. Here we have mass m equals to 5 kg. Lies on a rough horizontal platform. If the horizontal force F, that's the force applied on the mass, is what? 8 Newton. So let me just sketch it. When answering picture, it's good to picture things very well. So they said this is the horizontal platform and a block of mass is resting on it. So if a force applied on it, that force is F. Or that force, let's call it P, or we call it F. Hmm? Applied on it through its center of mass, just slide the block on the platform. So that force is able to slide that block, which means that force is able to overcome the the limiting frictional force. So we should find the coefficient of friction. Coefficient of friction represented by letter mu is what we are now looking for. So remember that a limiting frictional force, that's the maximum force required, the maximum force that has to be overcome before a body slides on a surface, equals to what? Coefficient of friction times normal reaction. And normal reaction is what? Is a force that acts in opposite direction to the weight of that body. This is normal reaction, while here is the weight. So in magnitude, both R and W are the same. So normal reaction equals to weight, but it acts in opposite direction to that. So we have to find what? Mu, coefficient of friction. If we make mu the subject of the formula by dividing both sides by R, you have that mu equals to what? Limiting frictional force divided by what? Normal reaction. Normal reaction. And then we have been given limiting frictional force to be what? 8 Newton. Normal reaction will be what? Mass times gravitational acceleration. And the mass here is 5. And the gravitational acceleration is usually 10, approximately 10 meter per second squared. So this is 8 divided by 5 times 10, that's 8 divided by 50. So our coefficient of friction, if you do that math, 8 divided by 50, that will give you 0.16. So the coefficient of friction for between the block and the platform is 0.16. So the roughness of the surface is 0.16. This means that the surface is not that rough. Hmm? Coefficient of friction ranges from 0 point any two decimal place number to 1. Zero coefficient of friction can never be greater than 1. So if the surface is very very rough, the coefficient of friction will lie around 0.9, 0.8. That's to show it's very very rough. But if the surface is not that rough, it will lie between 0.1, 0.0 something, 0.2. So here the coefficient of friction is small. So the answer to that is 0.16.